Hello, I'm John Linz, and in this video I'd like to discuss the Softmax activation function. In a previous video I discussed some popular activation functions, yet I've yet to talk about the Softmax, and the reason for that is because it works a little differently. The softmax is usually put at the end of a neural network to normalize it, and I will discuss that in this slide. So the softmax it takes a vector input and it creates a probability distribution. So it takes an input vector and creates an output vector, and each element of the output vector is a probability, which corresponds to each element in the vector. Now, when I say normalize, you can normalize the output of a neural network using nearly any activation function. So, for example, if you wanted to normalize the output on a range from 0 to 1, well, you could just use the sigmoid activation function. But in the case that you want to use probabilities, then you'd have to use the softmax. So here's an example of a Python script. And I'm not going to go into detail of what's happening right now. I'll do that in the next slide. But just to give you an overview of what you should expect, as you can see here, given an input, here we have a vector of 6 elements. We have 6.3, 7, 1.2, blah, blah, blah. What we can do is create a probability distribution. And if you've noticed, where elements are the same number or the same scalar value, we are getting the same probability. So for 6.3, we're getting 16.5%, and for 7, we're getting 33.3%, as you can see in these two cases. And of course, all of these probabilities will sum up to 100% or to 1. So how does it work exactly? So given a vector input, what you do is take e to the power of each element in the vector, and we're dividing it by the sum of e to the power of every element in the vector. So to give you more of an intuition, here I am simply taking e to the power of every element in the input vector, and this is using the input vector from the previous slide, and we're getting 3,293.119. Then to construct our probability vector, we're taking e to the power of each element here, but in this case, we're now dividing it by this sum, and we're creating our probability vector, and this is the same vector as last time. Now, to get even more of an intuition, here is a graphical visualization of what's actually happening. This dotted black line you can think of as the actual softmax function in a sense, and given these inputs to x, which is each element of our vector, this y value is the probability. So the applications of the softmax activation function ranges from NLP to reinforcement learning. Of course, there are many more applications out there, but these are two very, very popular uses. So in natural language processing, when we want to create or construct word vector representations of words, and this is actually going to be in a future workshop where I discussed skipgram, you need to use the softmax activation function to create a probability distribution of all the possible context words occurring given a center word in a given corpus. And it's also used in reinforcement learning when an agent in a simulation wants to know what action it should take to bear a higher chance or probability of a certain reward. And that is all I have for you. So thank you so much for watching. Goodbye.